Hi, let's learn spectroscopy in this one slide. Spectroscopy is interaction between electromagnetic radiation and matter. Electromagnetic radiation consists of waves of the electromagnetic field. In other simple words, radiation is energy that travels and is spread out as it goes. And what is important to a spectroscopy concept is the interaction of that energy with that specific matter. Two types of electromagnetic radiation which you are familiar with are the visible light that comes from a lamp in your house and the Wi-Fi waves that comes from a Wi-Fi modem. A spectroscopy is a tool for studying the structures because atoms and molecules have unique spectra. As a result, these spectra can be used to detect, identify, and quantify information about atoms and molecules. But how? We will learn in a few minutes later. The other types of electromagnetic radiation that make up the electromagnetic spectrum are microwaves, infrared light, ultraviolet light, X-rays, and gamma rays. Now shall we begin microscopy concept about all these spectra. Radio waves is used to broadcast radio and television. Microwave radiation is used in microwave oven for cooking in a minute. Infrared waves transmit heat from sun, fires, and other radiators. And as long as we are faced to infrared light, we sense heat. Infrared waves transmit heat from sun, fires, and radiators. And as long as we are faced to infrared light, we sense heat. Our eyes only detect a limited range of this spectrum, which is visible light. Fireflies, light bulbs, and stars all emit visible light. Ultraviolet radiation is emitted by the sun and are the reason skin tans and burns. X-ray waves is used to view inside of the bodies or objects. For example, a dentist uses X-ray to image your teeth, and airport security uses them to see through your bag. Gamma ray waves have the most energy between all these waves. Doctors use gamma ray imaging to see inside your body, and is used in medicine for killing cancer cells. So what is the relationship between wavelengths and their energy? Energy is directly proportional to frequency and inversely proportional to wavelengths. Based on this formula, you can see that waves with higher frequency have higher energy, but lower wavelengths. As we saw here, radiations with higher wavelengths have lower energy. But as long as we go toward right of this chart, we can see that lower wavelengths have higher energy. Pay attention that here, higher energy helped us to see inside of the body, and more to the right side, we are able to even kill the specific cell inside of the body. But how we use them in a spectroscopy? We need to learn two concepts. First concept, let's focus on the region of electromagnetic spectrum which was visible by our eyes. When a light encounters an object, we can see that they are either transmitted, reflected, absorbed, refracted, polarized, diffracted, or scattered, depending on the composition of the object and the wavelengths of light. This concept can happen in other part of this spectrum chart, but just we are not able to see them. Second concept, whenever you give energy to a matter, you will have an excitation. Light energy or electromagnetic radiation excites electron from the ground state to the first singlet excited state of the compound or material. Consider energy is like a sugar and matter is a person. Whenever a person eats sugar, they will have more energy. All types of spectroscopy use this simple rule that I just said. The only difference is the type of layer and transition. In all our classes, we saw ground state and excited state like this here. But let's have a look at this atom and repeat that important role for better vision and comprehension. Light energy or electromagnetic radiation excites electron from the ground state from here to the first singlet excited state to here. This is called excitation or absorption. But whenever this excited electron emits energy or light and goes back to ground state, we will have emission or relaxation. How about the other types of electromagnetic radiations? The nature of that interaction depends on the energy available. As you can see here, in an atom, we have different types of state or level We have electronic state, we have rotational state, and vibrational state. Ultraviolet and visible have sufficient energy to affect electronic transition. So we have a UV spectroscopy. Infrared has sufficient energy only to affect transition between vibrational energy state from here to here. So we have IR spectroscopy. Microwave has only enough energy to affect transition between rotational energy state. Thus, the radiation absorbed tells us different information. Radio waves have insufficient energy to affect molecules, but affect nuclear spin energy states found in magnetic field. This latter interaction is the most important because it is used in nuclear magnetic resonance spectroscopy. As you can see here, this energy is enough to excite electron from here to here and change the spin of that specific electron. A summary of what we just said is here in this chart. I hope you learn and enjoy, and I am thankful if you give a thumbs up to this video and subscribe our channel if you think it was helpful. You can download this one slide in the link below.